in this video lecture, we're going to look at a few problems based on non-linear filters used for smoothing, right? So smoothing spatial filters, we did numericals on these filters in one of the previous videos. So, and I have already created a detailed video on this topic. So I'll link that. I'll put the link to that video in the description and also in the I button. So let's see. And in the end of this video, I will also tell you how you can apply these filters for a specific type of noise. How will you choose which filter to use for which noise? Because ultimately filters are used to remove noise from the image as well, apart from performing smoothing and sharpening. So let's start. Non-linear filters, as name suggests, are not linear. They are non-linear filters, and as I told you before, they are based on ordering or ranking of the pixels, right? And that's why they're also called order statistic filters. And ranking meaning that you have to rank all the pixels either in ascending order or in descending order. Okay, so let's see. We have, right, ascending order would be increasing 1 to 3, descending meaning 3 to 1, right? So based on this ascending and descending order, we have a median filter. Median, as name suggests, it will find the median of the median, right, using the given sequence of pixels. And then we also have min filter and max filter. Min filter, as the name suggests, it will choose the minimum value, and the max filter, as the name suggests, it will choose the maximum value. Okay, now let's see how these filters work one by one. We'll take a few examples. And median filter, as I told you, this filter works with ascending or descending. You can ascend, you can keep the values in ascending order, or you can keep the values in descending order, because ultimately it's going to choose the middle value. Okay, so when I say the middle one, the median, it irrespective of whether the sequence is in ascending order or in descending order, it will always pick the median middle value. Okay, so let's see how it works. So first we'll see the application of median filter. As you can see, we have an image here, okay, and all these are the pixel values. Okay, so we want to apply median filter on this specific pixel. And when I say we want to apply a median filter on an image, you will always target one of the pixels, okay? And it could be that if you want to apply it on all the pixels, then you will start with 10, 12, 20, like you will target individual pixel. Okay, so I'm just taking an example. This is an illustration. So I'm just gonna take this one example and show you how to apply filter on this pixel. If you want to, so when I apply it on 27, I will choose neighborhood pixels. Similarly, if you want to apply it on 88, you will choose the neighborhood pixels of 88. If you want to apply it on 69, you will choose the neighborhood pixels of 69. And therefore, your neighborhood pixel matrix will have different values for different pixels based on which pixel you want to apply the filter, right? So this is, if this is the image with all the pixel values, we want to apply it on 27. We'll first choose 3 by 3 neighborhood matrix. So for 27, this is the neighborhood matrix, and I think you know it's really easy. You can easily choose the neighborhood matrix. It has to be 3 by 3, and the pixel that we are targeting should be the center pixel. So based on that, pick the immediate two values to the left and right, and the diagonal values, and these values above and below, right? This will this will make your 3 by 3 neighborhood matrix for that specific pixel. Next, we want to apply median filter. So for that, we will use all the pixel values of this matrix. Okay, just write them. So we have 10, 18, 25, 97, 27, 19, 18, 75, 69. Once you write them, as I told you, you can use the ascending order or descending order. I've picked ascending order. So I'll put all these values in ascending order. And even if you put them in descending order, you will take 97 first, then 75, then 69, then 27, then 25, then this, right? You can start from the right hand side or you can start from the left hand side if I'm using ascending order, right? And you have to pick the middle value. So how do you do that? Leave equal number of pixels on both sides. And since we had two same values here, 18, 18, I've taken them like this. Okay, if there are same values, and the median is 25. So I leave 4 pixels here, 4 pixels here. We have 25. So we'll replace 27 with 25, and this is the resultant image. Okay. Similarly, you can apply this filter on every pixel if you want. This is how median filter works, right? Median meaning you are finding the middle value, average, you know. So this is how you calculate the median, right? Now let's see how you can find the min filter, how you can apply min filter. We'll apply it on this same image, on this same pixel. And again, you have to first choose 3 by 3 matrix, neighborhood matrix. It will be the same, obviously. 2 immediate pixels, left and right diagonal pixels, and then above and below. So we have 3 by 3 matrix here. Once you do that, you'll just write all the numbers, all the pixel values. Okay. And since this is min filter, you don't have to order the values. You don't have to put them in ascending or descending order, because ultimately you have to find the minimum value. So you can just look at the matrix and select the minimum value, or if it makes things easier, you can just write all the values down and then pick the minimum, the smallest one. So we have 10 here. 10 is the smallest one, so we'll replace 27 with 10, the minimum value. Okay. And similarly, if you're using max filter, I'm going to apply this filter on this same value. You're going to choose the largest maximum value. So again, neighborhood matrix will remain the same, and the maximum value that we can have here is 97 among all these values. Okay, so we'll replace 27 with 97, and this is the final matrix, resultant matrix. And now I would like to answer a few questions related to this topic. Give me a second. This is how these filters remove noise. Okay, so how these filters remove noise? We are specifically going to talk about two types of noise here. We have salt noise. Actually, I should write it like this, but this will not be visible, right? And we also have pepper noise. Okay, now when we talk about noise in an image, noise doesn't mean that there are some obviously external entities, but how is noise created in an image? It tampers with the pixel values. Okay, so whenever there is noise, it means that certain pixel values are changed, or certain pixel values are, so for example, see, if we have something, let's say I have this image here and I want it to have this color. Okay, but if some problem is created, right, there is some issue or some sort, and these two colors are like little bit similar, but they have different pixel values in terms of intensity, like their intensity is different, right? This one looks more brighter, and this one, I think, I mean, like, again, depends on the perception, but these values are different. Okay, so if I want this color, this will be the noise, right? Because of even the slightest difference in pixel values can create noise, right? So point is, when we say salt and pepper noise, because there are different types of noise, but we are going to talk about these two here. When I say salt noise, salt is of white color, right? So usually when the pixels are bright, brightest pixels create salt noise. Like all the pixels have certain value, all the pixels will come with certain value, but then there is this one pixel and it's the brightest. Okay, that creates salt noise. And you can remember this concept by the example of salt. Salt is white in color, right? So white, brightest pixel. And these pixels usually have values like 255 is the maximum. So any pixel with maximum value in the, like among all the pixels, this pixel will have the brightest value, the maximum value, right? So this will create salt noise. Example, again, it will look something like this, right? Salt noise, white. It will be white in color. And pepper noise is the opposite. So salt is of white color, pepper is of black color, right? So this will be the darkest pixel, and usually the values are 0, value is 0. Or if you have an image where all the values are you have very good values, and then there is one pixel with this value less than other values, right? This is going to create pepper noise. So for example, this is white, right? Okay, so like this, pepper noise. Okay, I hope the concept is clear. Basically, just remember that where did it go? In pepper noise, pepper noise is created by the pixel with minimum value, okay? Or the value will be the smallest when compared with other values. And you can see I have two images here. So consider this first image, okay? And these are all the pixel values. So if you see 1 2 2 1 10 2 2 1 1, so I mean, as compared to all these other values, this is the largest. Maximum value is 10. So this is going to create salt noise, okay? And similarly in this picture, in this image, this one, all these values are 19 21 21 18, like similar range, right? But this one, this is the smallest. When you compare one with all these values, this is the smallest, right? So this one is going to create pepper noise in the image, okay? This is going to create pepper noise, and this is going to create salt noise, okay? Now we've already covered min filter and max filter. You can easily tell which filter should be used to remove salt noise and to remove pepper noise. So here we have salt noise because of this brightest pixel, okay? And which filter should be applied to remove this noise? Obviously min filter, because min filter, when we work with this image, with this neighborhood matrix for this pixel, when we apply min filter, it will select the minimum value, okay, the smallest value. And obviously when you apply min filter here, smallest value will be 1, and this also means that this 10 will be replaced by 1. Okay, and when it is replaced by 1, it's not going to be salt noise anymore, because all the values are similar, almost similar, not the same, but they are similar, right? So you'll apply min filter so that the frequencies or the intensities are even, they are even out, right? They are uniform. Yeah, uniform is the better word. So they are uniform. Similarly here, since we have 1 here, so the smallest value, pepper noise, we have to have value similar to all these values, obviously. And when you compare 1 with 21 or 19 or 18, this is the smallest, so we want something more. And so we can apply which filter here? We'll apply max filter. And when you apply max filter, the value that you can select is the largest, maximum is 22. So this 1 is replaced 22. It's replaced with 22. And okay, intensities are like, you have to keep it uniform, okay, to remove the noise. And median filter, obviously, a median filter can be used for both types of noise. And I just wanted you to understand the application of min and max filter when it comes to salt and pepper noise. And this is it for today's lecture. I'll see you in the next video lecture. For any doubts, please feel free to ask in the comments. And I'll see you in the next video lecture. Till then, take care.